Hello everyone, so today we are going to continue working on how to find slope in multiple methods. So let's go back to the definition real quick first to begin. What is slope? So again, slope can be thought of in multiple ways, but a basic definition is just the steepness of a line or the rate of change in a line. So meaning how much does it change vertically versus how much it changes horizontally. So that's the rise over the run. Or you can just think of it out of the steepness of the line, meaning the angle of the line. So how steep is it in terms of like a hill or a mountain? How much of an angle does that hill have? How difficult would it be to go up and down? And we've gone over multiple ways of finding slope. So we've gone over how to find the slope from just an equation, how to find the slope from the graph, how to find the slope from a table, and today we're going to go over the last one, how to find the slope from 2 points. Again, certain methods work differently depending on what kind of problem you have. You'll pick a different method to figure out what the slope of a line is. So let's go ahead and look at what the formula is for the slope of a line when we have two given points. And we call this the algebraic method because we have to use algebra to solve for it. So with the graph, we would say that we'd be solving it graphically. Equation and table don't necessarily have a special name. So let's go ahead and look at what the formula is for slope when you're given 2 points. So the first important thing is to realize that you need to have 2 points. If you have more, that's fine, but you just need to use 2 of them. So we'll call them point XY and the other XY as well. Now, we need to be able to distinguish between these 2 points, so we got to name them slightly differently. We're going to call them x1, y1. So it's the y value of the first point, x of 2 and y's of 2. Those are the x values and y values of the second point. So we're just putting the 1 and 2 to distinguish the x from the first one and the x from the second point. Same thing for the y and of the first point and the y of the second point. So my formula is the following. So the slope m is equal, remember it's rise over run. Rise has to do with the vertical change, which means we're going to subtract the y's. Generally we write it y2 minus y1. If it's backwards, it doesn't matter. And x2 minus x1. So again, notice that the 2's match up and the 1's match up vertically. If you want to write it backwards, if you want to write it like this, whoops, not like that, like this, it's the same thing. You can just think of it any way you want. So again, as long as the top you're subtracting the y's and on the bottom you're subtracting the x's for the run, and in the same order, it doesn't matter which of the 2 formulas you use. So let's go ahead and see how this works in action. And the reason we want to be able to do this is because you may ask, like, I can just graph the 2 points, connect the line, and count. But when you have very big numbers, you probably don't want to do that when you don't already have a pre-made grid. It just makes it that much more difficult to do that, but it's totally possible for you to graph these by hand and then count graphically instead of doing it algebraically, but sometimes it's just easier to use the formula and it's a little faster. So again, let's go ahead and figure out the slope of the first line. So we know that this is x1, y1, this is x2, y2. So in my formula, I'm going to subtract the y's at the top. So I'm going to subtract the 27 with the 3. So I'm going to put 27 minus 3. On the bottom, I'm going to subtract the 13 with the 5. So again, subtract the y's on the top, subtract the x's on the bottom, and then just simplify from there. That's 24 divided by 8. Can I reduce this or can I divide this nicely? So in this case, 8 does go into 24, so my final answer would be just 3. So this line has a positive slope, which means this line is going in the upward direction. Let's go ahead and move on to the next one. Let's go ahead and identify our x's and y's. Remember, first one is both of these have 1's. Both of these have 2's for the second point. And we start off by subtracting. So again, we're going to subtract the y's, 15 and 9. So 15 minus 9. At the bottom, we're going to subtract the x's, 7 minus 3, so negative 3, I'm sorry. You got to be very careful because we have this double negative. So make sure you write down subtraction, then the negative. So make sure you're very aware of that fact. Don't just go 7 minus 3, 4. You'll get it wrong. So 15 minus 9 is 6. 7 minus a negative 3, this becomes a 7 plus 3, which gives us a 10. Now we're going to go ahead and simplify this. Does 10 go into 6? No, so we can't divide it nicely, but we can reduce. So I'm going to go ahead and reduce these by 2. So my answer is going to be 3/5. Again, we have another one with a positive slope. That means it's going up. Let's go ahead and move on to number 3. Same idea. We're going to start with m equals for slope. So m equals, again, we're going to subtract the x's, which is a negative 15, and the negative 5. So I have negative 15 subtracted by a negative 5. We have a double negative. Those are the ones we have to be careful with. And 3 minus 1, 3 minus 1. So again, the double negative here becomes a positive 5, but we still have a negative 15. So we have negative 15 positive 5, we get negative 10. Over 3 minus 1 is 2. This one actually divides nicely, so we're going to end up with negative 5. This is a negative slope, which means my line is going down. And the last one, let's go ahead and put our m equals. Remember, x1, y1, x2, y2. So we're going to go ahead and subtract. So 8 minus a negative 2, so it's 8, take away a negative 2, double negative, and then we have 5 minus 5. So remember this double negative, it gives me 8 plus 2, which is 10. Denominator is 5 minus 5, which is 0. So we got to simplify this. So we have 10 divided by 0, but wait, you cannot divide by 0. So we have a rule that in math that we can't divide by 0. So that means there's no way that's going to happen. You'll get an error in any calculator you try it out. 0 goes into, you can't take something and split it into 0 parts. This is going to be our special case when the slope does not exist. So we say that's undefined. So again, when we have no slope existing, undefined means that my line is it's a vertical line. So vertical lines do not have a slope because they do not have an angle. So there's like no way to have like a mountain that goes vertically up. All right, let's go ahead and answer that bottom section about vertical and horizontal lines. It's very important to keep those two straight because they look very similar in a slope problem. So for vertical lines like we just went over, we have an undefined slope. Which means when we do our formula, after we do our subtraction here of the formula, we end up getting a 0 in the denominator. We get some number at the top, it can be any number, but the bottom is a 0. So when we get a 0 in the denominator versus the horizontal line, right? So this is vertical lines versus horizontal lines, where our slope, our slope has 0 slope. The slope is 0 because it doesn't rise, and it doesn't rise up, and it doesn't rise down. It just goes straight across. We call this constant. It doesn't go up or down. So this has a 0 slope, which means in our formula when we're doing it, because if we're not graphing it, we can't see it happening. That means there's a 0 at the top and some random number at the bottom. So when we do 0 divided by anything, the answer will always be 0. So when you get a 0, it's going to be a vertical or horizontal line. If it's a 0 in the denominator, undefined vertical line. If it's a 0 at the top, our answer is 0, which means it's a horizontal line. So this is what we get in our special cases. So just be very careful with vertical and horizontal lines and finding their slope. So go ahead and work on IXL and your practice pages, and good luck.